Math 3, Unit 4, Section 3. Today we're talking about adding and subtracting rational expressions, and we've split this into two sections. So first thing that we need to remember is that when we are adding or subtracting fractions, what do they need to have? A common denominator. So you'll notice that quite a few of the examples we're working with today, they do have like denominators or common denominators. And so once they have common denominators, what do? Yeah, you add or subtract across. So in this case, since we're adding, all we do is we keep our denominator the same, which is 7, and 3 plus 2 makes 5. At that point then, you would see if you can reduce. This one cannot. Now, when you're subtracting, I always suggest, because this subtraction sign is going to this whole fraction. So you know how sometimes you'll have more than one term on the top of a fraction? And so you're going to need to distribute that negative to everything on the top over here. In this case, there's just one number, which is 2. But so I normally bring the negative up with the 2, and I change that to a positive. And so then 3 minus 2 is what? 1 over 7. Okay, so again, in general, using letters here, this answer would be what? Good, A plus B over C, where this one over here, again, I'm going to bring the negative up with the B, is going to end up becoming what? A minus B over C. Questions so far? Okay, and be ready. I think I'm going to pull out some sticks today, so make sure you're paying attention. All right, adding expressions with like denominators. So what am I going to do on this first one? Is there anything that I need to change or do? Nope, so we're just going to add across, and what do I get? 5a over. Okay, can I reduce anything? Why am I not able to reduce those a's? Very good. You can't do a monomial and a binomial. These two are grouped together, correct? Is there a GCF or anything that I can take out of that group? No. And so there's nothing that can be reduced. This is my answer. Okay, next one here. Do we have common denominators? And so oftentimes I will just go and I'll rewrite my denominator because I know that's going to stay the same. And then I'll go back and simplify the top. And so I have a 3c and another c, which would make 4c, and then minus 14. Good. Can I factor or reduce anything? Okay, so on the top, what can I factor? I can take out a 2, and when I take out a 2, what am I left with? 2c minus 7. Very good. Can I factor anything out of the denominator? Good, a 4. And when I factor out a 4, what am I left with? 2c plus 7. Okay, do we notice anything that can reduce? The 2 and the 4. 2 divided by 2, that cancels out, and 4 divided by 2 makes this a 2. Now, is there any way of making these so that they're exactly the same? So if I took out a negative here on the bottom, that would make the 2c a negative and the 7 a negative. Would that make these the same? No. So it only works with the negative if you have one as a positive and one as a negative. See right here, the 2c is a positive, the 7's a negative. So you need one of these to be a negative, and they're both positives. So if I take out a negative, they both end up becoming a negative. So these cannot be reduced. Okay? So that means that my answer is just 2c minus 7 over 2 parentheses 2c plus 7. Do you guys want to ask me a question about that at all? So do we understand why these cannot cancel out? Because they're not exactly the same, right? This 7 is negative, this 7's positive. While the 2 c's are both positive, these are not the same, and the whole group has to be the same. Okay? And again, how come I can't reduce this 2 with this 2? Because it's connected, it's in this group, right? And so these are all connected together, and if you need to keep parentheses around that to remind you that they're connected, you can. All right, so next group, do these have common denominators? Yeah, and so we can go ahead and just rewrite our denominator. So 9 squared plus 4, 9 squared, n squared plus 4n plus 4. And then on the top, we just get n plus 2. Good. Can I factor or do anything here? Good. On the bottom. So on the bottom here, what multiplies to be 4 and adds to be 4? What numbers? 2 and 2. Good. Those both add to be 2 and multiply to be 2. And so how do I write that? Good. N plus 2, n plus 2. Bless you. And n plus 2 on the top. Can I reduce anything? Yes. And remember, we can only do 1 for 1. So only one of the n plus 2's can reduce. And so what is my answer going to be? Good. 1 over n plus 2. Make sure that if you have something left over and it's in the denominator, it stays on the denominator. If nothing's in the top, then there's actually a 1 there when you're reducing. Okay, so on this next part, you're going to notice that they are now like denominators that are subtracting. Okay, so again, when you have a subtracting sign, you're going to take that minus sign and distribute it up to the top. So in this case, the 7 is going to become a minus, and then we change this to a plus. We have a like denominator, so my denominator is going to be what? Good, z plus 3. And then what is 2 minus 7? Good. Can I reduce anything? No. Okay, next example. My denominators are the same, so I'm going to go ahead and write my denominator is 10n minus 4. And what am I going to do next? We're going to make it a positive by doing what? Very good, distributing the negative through. So when I distribute this negative, the 3n is going to become a negative, and the 5 is going to become a negative. And then we can change this to a plus once I distribute that negative through. And so 9n and negative 3n makes 6n, and negative 3 and negative 5 makes negative 8. Can I factor or reduce here at all? Yes. Okay, so the top, what can I do? Factor out of 2, and we're left with, very good, and the denominator, what can I do? Factor out of 2, and I'm left with, good, 5n minus 2, and can I reduce anything? The 2's, very good. Can I reduce anything else? Nope, because these are connected, right? Anytime you have minuses and pluses, they're connected. So we get 3n minus 4 and 5n minus 2. Dustin, you getting this? Okay. So I'm going to go ahead and draw a stick for this next one. I want you to look at the problem. And my question is, what would be your first step? There's actually a couple options. Neither one is right or wrong. So think about what you would personally do first on this problem. Kobe, what would you do? Okay, so Kobe would factor the denominators. Would you rewrite it over here? Okay, so when you factor these, what did you notice? Good, difference of squares, so that's going to make what? Perfect, q plus 2 and q minus 2. And again, you could have done a different first step, which is fine, but now based on how this is written, what are you going to do next? So talk to your partner real quick what you would do next at this point. Okay, so I'm going to go ahead and pull a stick now, and Denise. That's funny that we're still in your group. Okay, what would you do? Distribute what? The negative to the top, and so what ends up happening? Good, so this becomes a negative, this becomes a positive, which changes this to a positive. Very good. Okay, so next thing, what am I going to do? Isaac.
Distribute negative, then you add together.
Good, combine your like terms. So we have a 7q and a minus 6q, and what do those make? Q. And then negative 3 and 5 make what? Plus 2. Perfect. Okay, look at that. What can we do now? Please help me out. Colton.
Let's look for, see if you can reduce.
Yeah, do you notice anything? I see you don't have your glasses, so sorry. Do you know? Can anybody help him out? Sochi, go ahead. Good. There is a q plus 2 on both the top and the bottom, so we can cancel those out. And how would I end up writing my final answer, Jordan? 1 over q minus 2. Good. Okay, any questions? Yes. So that was the step that you actually helped me on. So because you have that minus sign, the minus sign needs to go to either the top or the bottom of the fraction. Okay, and so because on that we want to keep our denominators the same, I'm going to distribute the negative to the top, and so this becomes a minus and this becomes a minus. It's almost like, you know, when you have a problem, let's say like if I had 7 minus 3 parenthesis x plus 2, something like that, that minus 3 would go through this whole parenthesis, and so that's what's happening here. This minus needs to go to the whole top or the whole bottom, and we're choosing it to take it to the top because the bottom, we want to keep those as like denominators. All right, other questions? Yes?
So for
Up here?
yeah. So that you couldn't take out the 2, is it because the top one is in the
What, you mean this 2 right here?
Yeah.
So that 2 is connected to the c minus 7. It's a group. Good luck today, you guys. So you can't, anything that is connected with a plus or minus, I almost think of them as like connected together like glue. And so the only way to reduce them and get rid of them is if everything is exactly the same. And so the 2c minus 7 and the 2c plus 7, they aren't exactly the same. Here we could reduce because these were monomials in front, and so we could reduce those. But back here, this is a binomial, and so it can't reduce with the monomial. Does that explain your question? Okay. Anything else right now? All right, let's move on to the back side. So now we're going to deal with some unlike denominators. What do you notice first about this one right here? They're reversed, right? And so how could we make them so that they're the same? If we took out a negative, okay? And so if I were to take out a negative in the denominator here, that would make this 2 a negative and the x a positive. Okay, and to show this to you, I'm going to rewrite this again. So on the first fraction, I still have 5 over x minus 2. Since I took out a negative, you have this positive and negative here now. So I'm going to change that to what? So when you have a positive and a negative sign, what is a positive times a negative? A negative. So that's like a minus sign now in between your fractions. You know, I'm going to wait and try not to confuse you. Okay, and so I'm going to flip this around now and write this as x minus 2. So when you have a negative, you can bring it to the front. It could go with the, it can go to like the whole fraction. It can go to the bottom of the fraction and go to the top of the fraction. Am I making any sense? So like, let's just do a side note here for a second. If I have negative 1/2, this negative could be with the 1. I could have negative 1 over positive 2. Or we could write this as 1 over negative 2. Or it could just be out in the front of both of them like this as negative 1/2. But basically there is just one negative. Okay, so it doesn't matter if it's with the top, it doesn't matter if it's the bottom, it doesn't matter if it's in the, there like with the whole entire fraction. Okay, so that is the same thing here when you're taking out this negative. the negative could just be in front of the entire fraction. And so that's what I've ended up doing right here. And there was already a positive here. So positive and a negative make a negative. Had there been, let's say, a negative there, two negatives would end up making that a positive. Okay? So the top right now is still 3. Now, what do I actually end up wanting to do with that negative, though? Yeah, bring it to the top and make it a positive. So I'm going to end up putting that negative up with the top and making that a positive. And so what does my answer end up being? Good. 2 over x minus 2. And can I reduce anything? No. And why can't I reduce these 2's? Yeah, monomial, binomial. This is stuck together, and I cannot reduce binomials with monomials. Yes, Destiny.
When you take out the negative and you change the sign into a negative, or yeah, into a negative, why does it have to change into you multiply it, but you're not multiplying?
You actually kind of are. It's like a -1. When you're taking out a negative, it's a -1. And you just have that plus in there. If you wanted to just take this negative and just bring it straight up to the top, you could do that as well. Instead of bringing it to the middle and then to the top. So remember when you take out a negative, how I said it could go out in front, which is where I originally put it, or it could go with the top or the bottom. You could have just taken the negative and then brought it up to the top if you wanted to. When you're factoring on a negative, though, it's a -1 that you're actually taking out. And a negative and a positive make a negative. Like if you have, let's do another side note here. If I had like 5 plus -3, okay, this is the same thing as 5 minus 3. Whenever you have a positive and negative, it makes a negative. Okay, but if I had something like 6 minus a -2, two negatives side by side make a.
I didn't understand how you just like switch the sign.
Well, I didn't switch the sign. I had a positive and a negative. And a positive and a negative make a negative. What we did right here is the same thing as right here. Okay? We can come back to it again later. Okay? All right, so what would be the common denominator in this fraction? Yeah, so 5 and 3 have nothing in common, so 15 would be our number. And then this has 5 m's, and this has 2 m's. Well, basically you just have to take whichever one is your highest exponent, because I could multiply this by m to the 3rd, which would end up making m to the 5th.
Just wanting to let all special ed teachers know you are meeting in Ray Harlow's room, C29. That's all special ed teachers will be meeting in C29 this morning.
Okay, so my common denominator is going to be 15m to the 5th.
Wait, why is it 15 to the 5th?
What do you want it to be?
Well, no, why? Okay, so if how did you get the 5 on the other side of the 2? How does the 5? If you multiply
Talk about the m squared.
To the second side of that third, and then just add the 2x.
yes, would it change?
Okay, do you agree about the 5 and the 3 should make 15?
So I just multiply it by?
Okay, wait, do you agree that the common denominator for 5 and 3 would be 15? If we're just looking at the numbers first. Are you okay at the 15? Okay, so now we're just looking at the m's. So right here, m to the 5th is really 5 m's, right? 1, 2, 3, 4, 5 m's. Okay, m to the 2nd, there's really 2 m's. So the common denominator is going to end up being m to the 5th, because you have to at least have as many m's as there are in one of them.
15 to m7 if you multiply by 3m squared.
So listen up here. This, I already have 2 m's here, and this one has 5 m's, right? Well, I could multiply by m to the third here in order to make this 5m's. So I don't have to, the m's are all m's, correct? So m's aren't changing, they're like. So they have 2 in common. They each have 2 m's right now. But in order, since this one has 5, we have to have at least 5. You always have to have at least as big as the biggest number. But I don't need more than 5 because there isn't anything more than 5. So since 5 is my biggest, 5 is the most that I need. Okay? And so what I always do is, and I have a whole bunch of stuff written already over here, but what would I need to do to 5m to the 5th in order to make it 15m to the 5th? What would I need to do to that? Multiply by 3. And so I have to multiply 3 to the top and the bottom over here. And so 3 times 2 makes 6. Okay, and so all I did was I had to multiply the bottom by 3 in order to make it the 15m to the 5th. Now, over on this side, and we need to kind of cross some of the stuff out here, what do I need to multiply 3m to the 2nd by in order to make it 15m to the 5th? 5m to the 3rd. So I'm multiplying the top and the bottom by 5m to the 3rd in order to make that. So what does the top now become? 35m to the 3rd. Okay, and then now we can add. So we keep our denominator of 15m to the 5th. And then can I combine these? No. So we're just going to write that as, yeah, and I would write it in descending order like you did, 35m to the 3rd plus 6. If you didn't write in descending order and you wrote 6 first, that's fine. Okay, and we can't reduce anything. That's my answer. Okay, so do you understand how we're trying to make these so they're like denominators? And so the most we need is whatever the highest exponent is, because we can multiply the other one to bring it up to that point. Okay? Now this one's a little different because we have an m plus 2 and an m plus 2 and an m minus 7. Those are both binomials. And so what do we have to do on these? What would be my common denominator? So we have 2 binomials. It's actually just going to be both of those. So it's going to be m plus 2 and m minus 7 is going to be your common denominator. Yep. And so if you have 2 different binomials, you're going to be multiplying each of them. Okay, so what am I missing on this first fraction? What do I have to multiply m plus 2 by in order to make it the m plus 2 m minus 7? M minus 7. So that means that what I'm doing is I'm multiplying the top and the bottom by m minus 7. Now there's already a 9 here. So what do you think I'm going to do? Exactly. We're going to go 9 times m, which is 9m. And then 9 times negative 7, which is negative 63. Good. Now in the second fraction, what am I missing? Good. So I already have the m minus 7, but in order to make it the m minus 7, m plus 2, I need an m plus 2. And so I have to multiply the top and the bottom by m plus 2. And I'm going to do what? Distribute, right? So 8 times m makes 8m, and 8 times 2 makes 16. And we can combine like terms. And so 9m and 8m makes 17m, and negative 63 and 16 makes what?
You don't simplify all these?
Yes, you will. What, did I miss something that I could have simplified that we didn't?
Why didn't you leave it as 9 times n minus 7 and then cross out n minus 7 on both?
Because then you wouldn't have common denominators in order to make it a single fraction. So in order to add fractions, they have to have common denominators. So I got the common denominators, so now I had to distribute to then add them together. And then if I can factor and simplify, I will. So what is negative 63 plus 16?
Negative
negative 57, 47? Thank you. Over m plus 2 and m minus 7. And is there any like terms here that I could factor out? Is there anything? Nope. And so this ends up being my final answer. If I could factor something out and reduce, I would. But we can't reduce until it's one single fraction. Okay? So let's try this now with subtracting. Based on what we did on this example here with our m's, what do you think my common denominator is going to be here? 10h to the second is correct. So I'm just going to rewrite this with my common denominators. And then I go back to this problem. And what do I have to multiply 10h to the second by in order to make it 10h to the second? 1 or nothing, right? So this is already like terms for the first term. So we keep the top the same. I didn't have to do anything in order to make it be that denominator. Now on the 5h, what do I have to multiply that by in order to make it 10h squared? 2h. So whatever we do the bottom, we have to do to the top. So what is 4 times 2h? Good, 8h. And then what are we doing with that subtraction sign? Distributing to the top. So that just becomes a negative, and we change that to a positive. And then how will we end up writing this? And is there anything I can factor out or do to simplify? No. This doesn't have any like terms. If you wanted to factor out a negative 1, you could, but it's okay. You can leave it that way. Yes? Why wouldn't I multiply 10 and what? Because 5 can go into 10. So we just want them to be the same. Now, if you did that, you could make your denominator 50h squared if you wanted to, and then you'll have to reduce at the end. And then when you reduce, you'll end up getting to this answer. Okay? But because 5 and 10, you can multiply 5 by 2 and make it 10. That makes it simpler, and you won't have to reduce as much. Okay, what is going to be my common denominator on this one? Anybody know? Very good. It's going to be x and x plus 3 because x is a monomial and x plus 3 is a binomial. And so we have to use both of them in order to make our common denominator. Okay, and so I'm going to rewrite these as my common denominator, x and x plus 3. So what will I multiply this one by? X plus 3 in order to get it to that common denominator. And so what will I do with the top? Good, we're going to distribute. So 11x, 11 times x is 11x, and 11 times 3 is 33. Good. Okay, over here, what am I going to have to multiply the top and bottom by? X. Okay, and so 4 times x makes 4x. But what do I have to do now? Good, distribute that negative. So the 4x becomes a minus, and then this becomes a plus. And 11x minus 4x makes 7x plus 33 over x times x plus 3. And can I factor anything out? Oops. No. And so this is my answer. Do we have questions right now? Okay. What is the denominator of the 5? 1. So what will be my common denominator on this problem? 3c minus 1. So I'm going to rewrite this with the 3c minus 1 for the denominators on both the fractions. Do we see how this is already 3c minus 1? So what will the top be? Just c plus 2. Since we don't have to multiply by anything, we don't have to multiply anything to the top, it stays the same. Now, what do I have to do to 1 in order to make it 3c minus 1? Good. Multiply by 3c minus 1. So we're going to do that to the top and the bottom. So on here, we're going to distribute the 5. 5 times 3c makes 15c, and 5 times negative 1 makes Negative 5, but then what do I have to do? Good, distribute the negative. And so the 15C becomes a negative, and the 5 becomes a positive. And once I distribute, then that minus that I distribute becomes a positive. So like terms, what's C and negative 15C? Negative 14C, good. And then 2 and 5 makes 7 over 3C minus 1. Is there anything I can factor in order to reduce? Good. We could factor out a 7, or even more specifically, we could factor out a negative 7. So when I factor out a negative 7, what am I left with? 2C minus 1. And again, if you're ever confused, just write divide by negative 7 on both of those terms so you can see it. And then we have 3C minus 1 on the denominator. Can I reduce anything? No. So we can just leave this as our answer. Do we have any questions right now?